Good morning children and welcome back to your chemistry class. So today in this chapter of redox reaction we shall continue studying the oxidation number, but here today I am going to tell you the concept of oxidation and reduction in terms of oxidation number, right? So when do we say it is oxidation, when do we say it is reduction in terms of oxidation number? So let's talk about when do we say it's an oxidation reaction. When there is increase in the oxidation number of any element in the given substance, then it is termed as oxidation, right? So when there is increase in oxidation number, then the substance is said to get oxidized, right? Similarly, when do we say that the substance has got reduced? When there is decrease in the oxidation number of the element in the given substance, then it is said to be a reduction, right? Now, what is oxidizing agent and reducing agent? Obviously, the substance which is getting oxidized is your reducing agent and the substance which is getting reduced is your oxidizing agent. So, this point according to oxidation number is very clear to you, that when the oxidation number is increasing, right, from the reactant to the product, then it is your oxidation, but if it is decreasing, then it is your reduction. Let's take an example to quote that it is a redox reaction on the basis of oxidation number. So let's take an example like phosphorus combines with oxygen to give phosphorus pentaoxide. So let me balance this. 5 and this becomes 2. Now this is a reaction given to you. Okay, so I need to find out whether this phosphorus and this oxygen, whether it is getting oxidized or reduced. So let us first find out the oxidation number. Now this phosphorus oxidation number is 0. If you remember the rules that I had made you write yesterday, so oxidation of the element will be 0. And what about this oxygen? This is also 0. Now let's see over here. For phosphorus, it will be plus 5 and for oxygen it is minus 2. So let's look over here. From phosphorus 0, it is increasing to plus 5. Over here, what did you see? The oxidation number is increasing. So when there is increase in oxidation number, what is happening from phosphorus to P2? What we see? Oxidation taking place. So over here it is oxidation. Is this point clear? Now let's look at this oxygen. From 0 to minus 2 means what? That your oxidation number got reduced. So when oxidation number is reduced, what is this? Here reduction is taking place. Okay, here what is happening? Reduction is taking place. Now tell me which one is your reducing agent and which one is your oxidizing agent. So let's look over here. Phosphorus is getting oxidized. So this is your reducing agent, isn't it? This becomes your reducing agent and your oxygen is getting reduced. So this is your oxidizing agent. I hope this example is clear to you, that oxidation and reduction in terms of oxidation number, how to understand which element is showing oxidation and which element is showing reduction. Okay. Now let's take another example like zinc combines with copper ion and forms Zn2 plus Cu. Okay. Now tell me which element over here or which ion over here, ion or this element is getting oxidized or reduced. So let's see over here, this is 0 and this is plus 2. Okay. So what is happening here? The oxidation number is increasing. So if oxidation number is increasing, therefore oxidation is taking place. Since oxidation is taking place, so this is also your good reducing agent. I hope this point is clear. Now if this is Cu2 plus, this is an element, a metal. So its oxidation number will be 0. So let's see over here what has happened. From +2 to 0, that means the oxidation number has decreased. Therefore, this, what is happening over here? Reduction is taking place. Now since copper ion is getting reduced, so this is what? Your oxidizing agent. I hope with these two examples it's very clear to you how to understand oxidation and reduction in terms of oxidation number. Okay, let's take one more example, like SnCl2 plus 2FeCl3 gives SnCl4 plus 2FeCl2. Now tell me over here, SnCl2 or FeCl3, which one is getting oxidized and which one is getting reduced? So here firstly we have to find out the oxidation number. So this is +2 because chlorine is +2 over here. Over here it is +4 because chlorine is 4 over here. So oxidation number of Sn, both the side is clear. Now chlorine, obviously this is -1. Over here also it is -1. Now let's talk about ferric chloride. Ferric chloride means this is +3 and chlorine will be -1. Over here it is +2 and this is -1. Right? Now let us see. Now chlorine over here in the reactant and in the product side, it is the oxidation number remains same. So we neglect seeing the chlorine. We have to check what? The tin Sn from +2 to +4. What is happening over here? Oxidation number is increasing. Therefore, oxidation is taking place. Whereas if you see over here from Fe3 it has gone to Fe2. So what is happening over here? The oxidation number is reduced. Therefore reduction is taking place. Right? If this is reduction taking place, then your FeCl3 is what? It is your oxidizing agent. And SnCl2 is what? This is your reducing agent. Now if Sn is getting oxidized, doesn't mean that only Sn is your reducing agent. The whole compound is your reducing agent. So we will say that SnCl2 is your reducing agent. Okay, and FeCl3 is the oxidizing agent. I hope till here everything is clear. Now, since I have shown you so many reactions, it doesn't mean that all such reactions, all the double decomposition reactions, they all show redox reaction. So let me give you certain examples where you are going to observe that there is no change in the difference of the oxidation number in the reactant and in the product side. Then we will say that such kind of a reaction does not show redox reaction. Okay, so let me take few examples, like copper sulfate plus 4NH3 gives CuNH3 whole 4 SO4. So this is the reaction. Right, now you have to tell me whether this reaction shows redox reaction or not. Right, so let us see. First write down all the oxidation numbers. So this is copper +2, sulfur +6, oxygen it is -2. Let's come to this nitrogen, it is -3, and hydrogen it is +1. Okay, now coming to copper over here, it is +2, nitrogen -3, hydrogen +1, sulfur is +6, and oxygen we already know -2. Now let us compare. Copper, the oxidation number in the reactant side is +2, product side +2. Sulfur +6, oxygen -2, oxygen -2. Nitrogen -3, nitrogen -3. Hydrogen +1, hydrogen +1. So what do we see? There is no change in the oxidation number of any atom. Thus we say that this reaction does not exhibit redox reaction. I hope this is very clear to you. So no change in oxidation number of any atom, therefore does not show redox reaction. Okay, let me give you one or more example to show you the same thing. Like Na2SO4 with BaCl2 gives BaSO4 plus NaCl. Let's see this reaction whether it is a redox reaction or not. So let's go ahead finding out the oxidation numbers. So for sodium it is +1, for sulfur +6, and for oxygen -2. For barium it is +2, for chlorine it is -1. For barium it is +2, sulfur it is +6, oxygen it is -2. For this one is 2. So balance it. So it is +1 and chlorine is -1. Now let's check. Sodium +1, sodium +1, sulfur +6, oxygen -2, oxygen -2, barium +2, barium +2, chlorine -1, chlorine -1. So what do we see? No change in oxidation number. Therefore, this reaction is also not a redox reaction. I hope this point is very clear. The concept of oxidation reduction in terms of oxidation number. If there is variation in the oxidation numbers, then only the redox reaction takes place. But if there is no variation in the oxidation number of the atoms, then we say that the reaction does not show redox reaction. With this, let's see one more reaction. CuSO4 plus 4Ki. It gives Cu2I2 plus K2SO4 plus I2. Now let's see this reaction. Does it exhibit redox reaction or not? So copper it is +2, sulfur it is +6, oxygen it is -2, potassium +1, iodine -1. Copper over here it is +1, iodine -1, potassium +1, sulfur +6, oxygen -2, and this is iodine, so 0. Now look over here. Copper from +2 to +1. That means oxidation number got decreased. So oxidation number got decreased means it shows reduction. Clear? Now sulfur +6, oxygen -2, potassium +1, potassium +1. But look at I, -1, over here it is -1, but over here it is 0. So from here if you see this, that is the oxidation number of iodine, which is -1, has increased to 0. So over here oxidation number has increased. So this shows your oxidation. Okay. So now since over here one atom, that is copper, and another iodine, they show increase and decrease in the oxidation number. Therefore such reaction, it is said to be a redox reaction. Is this point clear? So just looking at the reaction, we cannot observe that it is redox or not till we do not find out the oxidation number and study the increase and decrease in the oxidation numbers. So let us understand the different types of reactions. There are generally 4 types of reactions that we have to study. First one is thermal decomposition redox reaction. Okay, then second one is displacement redox reaction. Then third is combination reaction, and the fourth type of a reaction is disproportionate redox reaction. So these are the different types of reactions that we are going to study today. So let us begin with the first type, that is the thermal decomposition redox reaction. So this type of reaction, it involves the breakdown of the compound into two or more components, at least one of which must be in the elemental state. Okay, so let's see, for example, Ag2O on decomposition gives 2Ag plus half O2. Now what is our first work? To find out the oxidation numbers. So over here we know that oxygen is -2. So what is the oxidation number of silver? So we can write what? 2 atoms of silver are there. 2x minus 2 is equal to 0. So your 2x is equal to 2. So x is equal to 1. So we can say plus 1 is the oxidation number of silver over here. Right, now on heating, what did we get? We get a silver element. So your oxidation number will be 0. And what about this oxygen? Over here also it will be 0. Now let us see this silver. What has happened? From +1 it has gone to 0. So over here we see that oxidation number has decreased. So here reduction is taking place. Whereas if you look at oxygen, what has happened? To oxygen -2, this is -2, okay? This is -2. So from -2 to 0, that means over here oxidation number has increased. Therefore, it shows oxidation, right? So this is your thermal decomposition reaction. Over here if you see, what is the reducing agent? So over here your reducing agent will be oxygen and your oxidizing agent will be silver, right? Then we move to second type of reaction. First let me pick up combination reaction because that is simple one. Then I'll go to displacement reaction. Okay, so let's come to combination reaction. You already know what is combination reaction. When the reactants they combine to give us a single product, then they are termed as combination reaction. So let's take an example. Magnesium when combines with nitrogen gives us magnesium nitride. So does it show redox reaction? Let's see. Oxidation number 0, oxidation number 0. Over here magnesium, if we have to find out, so let us find out the oxidation number of magnesium. So 3 atoms of magnesium plus 3 2s are 6. This is equal to 0. So 3x is equal to 6. So x is equal to plus 2. Okay. So your oxidation number of magnesium will be plus 2. Now let's see what has happened from 0 to plus 2. That means oxidation number has increased. Therefore, it shows oxidation. And from here, what did we see? The number has decreased. So, oxidation number has decreased. So, reduction is taking place. So, we can say that combination reactions, they also show redox reaction. Clear? One more example, like Ca plus O2 gives CaO. So this is 0, this is 0, and over here this is plus 2, this is minus 2. So from here we see the oxidation number has increased, so oxidation is taking place. And here what do we observe? The oxidation number has reduced, so this shows reduction. So combination reactions also show redox reactions. Now let's come to the third kind, that is your displacement redox reaction. So in displacement redox reaction, we know that one element is replaced by the other over here. For example, if you remember Zn plus HCl, it is going to give us ZnCl2 plus H2, right? So let us see whether it is a redox reaction or not. So let's find out the oxidation numbers. On zinc it is 0, then for HCl it is plus 1, minus 1. Now over here zinc it is plus 2, isn't it? Plus 2, chlorine is minus 1, and hydrogen will be 0. So let's look at zinc. So from 0 to plus 2, that means oxidation number has increased, so it shows oxidation. Now look at hydrogen, from plus 1 to 0, that means oxidation number has reduced, therefore it shows reduction. I hope this point is very clear. So what are the oxidizing agent and reducing agent? I hope that also you have understood. Now over here you have to remember your activity series, right? And over here it can be learnt as your electrode potential or standard electrode potential. If you remember, we have lithium, potassium, barium, strontium, calcium, sodium, magnesium, aluminium, manganese and zinc. Then we have chromium, iron, cobalt, nickel, lead. Then we have hydrogen over here. Then copper, mercury, silver, gold, right? And if you remember your halogen series, then we have iodine, bromine, then it was chlorine and fluorine, right? So what do we know over here? Lower the element in the electrode potential series, it easily gets reduced. Higher elements will reduce the lower elements. So we can say it has the tendency to get reduced. Which ones? The lower elements have the tendency to get reduced, not the higher elements. So in other words, I can say that higher elements reduce the lower elements, but lower elements cannot reduce the higher elements. So reduction potential, it increases as we go down, or we can also say that the tendency to get reduced also increases as we move downwards. Okay. So now let us take some examples over here to understand. Let's talk about one reaction which is very common. Zinc plus copper sulfate gives zinc sulfate plus copper. Okay, and I reverse, if I write copper plus zinc sulfate gives copper sulfate plus zinc. Now which reaction is possible? Which of the two reaction is possible? So very quickly you will say that zinc, it is above copper. Zinc, which is above copper in the electrode series. So definitely this reaction is possible. But since copper cannot replace zinc, therefore this reaction is not possible. So this was all what we were trying to explain till class 10th. Now here in class 11th we have to explain this on the basis of our oxidation number. So let us observe the oxidation number of this. So over here let's do this equation. So the oxidation number of zinc is 0. That of copper is plus 2. That of sulfur is plus 6. Oxygen is minus 2. Zinc over here is plus 2. Plus 6 is sulfur. and -2 is oxygen, and this is 0, right? So now what do we see? From 0 to +2, that means oxidation number has increased. So it shows oxidation over here. Whereas if you look at copper, what has happened? From +2 to 0, that is, the oxidation number has decreased. So it shows reduction. Now with this reference we go to our this electrode potential or the standard electrode potential series and understand that zinc has to shows oxidation. That means it can replace copper, right? So obviously it is placed above copper, therefore this reaction is possible. Now why you said that this reaction is not possible? Yes, definitely, because copper is below zinc. It cannot displace zinc from zinc sulfate. Therefore this reaction is not possible. But now let us explain this with the help of oxidation number. So this is 0. Zinc over here +2, +6, -2. Copper is +2, +6, -2 is oxygen, and this is 0. So now let us look at copper. What has happened from 0 to +2? So over here we say the oxidation number has increased. Therefore it shows oxidation, right? Now over here let's look at zinc. Zinc, what has happened? The number has decreased. Oxidation number has decreased. Therefore it shows reduction. Is it possible for zinc to show reduction? Because zinc is above copper. It cannot show reduction, because as I said just now, what? That reduction is the lower elements have the tendency to get reduced. So which one is the lower element over here? Copper is the lower element than zinc. So copper has the tendency to get reduced, whereas in this reaction what are we seeing? The copper is getting oxidized. Therefore this reaction is not possible. What did I say? Why this reaction is not possible? As I used a statement that lower the element in the electrode series, it gets reduced easily. So which one is lower? Copper is lower. It should get reduced, but it is showing oxidation. So this reaction is not possible. I hope this is very clear to you. Okay, I'm going to ask you one interesting question. Let me know, can we stir a solution of nickel sulfate? Can you stir the solution of this nickel sulfate with zinc spoon or with the silver spoon? Which one is possible to stir this particular solution? Now remember, one of these spoons, as you add to nickel sulfate, will dissolve. So we cannot use that spoon. So which spoon do we need to use? Zinc spoon or silver spoon to stir nickel sulfate solution? So let's write down the reaction. Zinc plus nickel sulfate. It is going to give us zinc sulfate plus nickel. I am first using zinc spoon. Okay. Let's see, can we use zinc spoon? So over here this is 0, nickel is +2, sulfur is +6, oxygen is -2. Over here it is +2, +6, -2, and nickel is 0. So what happened to zinc? From 0 to +2. That means oxidation number has increased. Oxidation is taking place. Okay. Now look at nickel. From nickel +2 to -0. That means the oxidation number has decreased. So it shows reduction. Clear? Now since nickel, if you see over here, nickel is lower in the electrode series than your zinc. So what will happen? Reaction will take place. Since nickel, if you see over here, it is lower than zinc, right, in the standard electrode potential, so the reaction will take place. Hence we cannot stir the nickel sulfate with zinc spoon. Okay, this point is clear. Now let us talk about silver spoon. Let's see for the silver one. So let me rub the above. So now let us talk about silver when combines with nickel sulfate. It is going to give us Ag2SO4 plus nickel. So this is our oxidation number is 0. Over here it is plus 2 nickel. Over here this is plus 1 and nickel is 0. So silver from 0 to plus 1, that means oxidation is taking place and nickel reduction is taking place. Right? So this reaction is not possible. Why so it is not possible? Because silver has a tendency to get reduced, not nickel, right? And therefore silver spoon can be used to stir the nickel sulfate, as it will not bring about any change in the electrolyte, right? This silver is placed below nickel, so silver will not be able to replace nickel, right? Therefore we can use silver spoon to stir nickel sulfate instead of zinc spoon. I hope this displacement reaction is also very clear to you. We next move to the fourth kind of reaction, that is disproportionate reaction. Disproportionate redox reaction. Okay, in this type of a reaction, an element in one oxidation number is simultaneously getting oxidized and reduced, right? So let's look at one of the example, like P4 combines with NaOH and gives PH3 plus NaH2PO2. Now let's find out the oxidation number of all these elements. So phosphorus it's 0. Then for sodium, oxygen, hydrogen, you all know it will be the same. Let's talk about phosphorus over here. So X plus 3 is equal to 0. So X is equal to minus 3. So over here this is phosphorus is minus 3. Okay, where else is phosphorus? Over here. So let's see the oxidation number of phosphorus over here. So sodium is plus 1, hydrogen is plus 1 into 2, 2 plus phosphorus we have to find out, minus, it is minus 2 into 2 minus 4, all this is equal to 0. So X is equal to 4 minus 3, so this is X is 1. So over here the phosphorus is plus 1. So what did I say? In disproportionate redox reaction, one element we will see oxidation as well as reduction, both are taking place simultaneously. So let's watch over here and let's see it from here. So 0 is moving to minus 3. From 0 to minus 3, what has happened? Oxidation number has got reduced, so it is showing us reduction over here, right? But over here 0 to plus 1, that means oxidation number has increased, therefore it shows oxidation. So such a reaction, when one element in one oxidation state is simultaneously getting oxidized as well as reduced, then such kind of a reaction is called as disproportionate redox reaction. Okay, let's take one more example to understand this. I2 plus KOH, this is going to give Ki plus KOI plus H2O, right? So over here oxidation number of iodine will be 0. For potassium it is plus 1. Now potassium is written twice, iodine is also twice, so I am using both these oxidation numbers. So potassium over here is plus 1, iodine is minus 1. Now let us find out the oxidation number of iodine over here. So potassium is always plus 1 plus this is minus 2. So minus 2 plus X is equal to 0. So this becomes how much? 1 minus 2 plus X is 0. So x is equal to 2 minus 1, x is equal to 1, right? So this is plus 1 over here and this is also plus 1 over here. So now let us look at potassium. Potassium over here is plus 1, in the reactant also plus 1 and plus 1. So over here you see the oxidation number of potassium does not change. So now let us go to iodine. Iodine, it is 0 here and in Ki it is minus 1. So what is happening over here? The oxidation number is decreased. So here reduction is taking place. Where else we move? This one over here, the iodide from 0 to plus 1. That means oxidation number has increased. So it shows oxidation. So once again, they are also disproportionate redox reaction. Why so? Because in one type of reaction only, one element in one oxidation state with one oxidation state is simultaneously getting either oxidized and reduced simultaneously in the reaction. So it is called as disproportionate redox reaction. Okay. Now next video we will be talking about balancing, how to balance a chemical equation, and we need to study two methods to balance a chemical equation. What are they? The ion electron method, which is also called as your half reaction method, and the second one is an oxidation number method. Okay, so I'll try to teach both of these in the next video. So for today, thank you.